Okay, let's go over your final exam for Biology 142. We're going to go over it one question at a time. I say that there are 10 questions below, which there are, and then I am going to be asking you a random 5 of these. You might just get 4, you might get 5. It depends on, I guess, my mood. All right, on the first one, let's start off with this bicarbonate ion carbonic acid buffer system that's going to be super, super important for you to know. Hopefully you guys learned this first semester and we've continued it on. This has been a subject of the blood chapter, of the respiratory chapter, of the urinary chapter, of the endocrine chapter. It comes up a lot, right? And so hopefully by now you know what this thing is. First of all, what is the bicarbonate ion carbonic acid buffer system? Well, it is a buffer system that prevents radical shifts in pH. I know I write terribly. So that's what that is. That's a very simple, straightforward answer. What is it? That's what it is. When I ask you to please write it down and say all the parts, I'm sorry, I'm going to actually have to draw here. I need you to actually draw it. Water plus carbon dioxide, and you will write water underneath here because I say it's a label, and carbon dioxide. Carbon dioxide, please write better than me. When they combine, they form carbonic acid. This is not a mystery to you at this point, I hope, in the semester. When carbonic acid breaks down, it will release the hydrogen ion and also the bicarbonate ion. These you will have to know in the future with your anion gaps and everything else, so it's important to know this now. Bicarbonate ion, excuse me. And these arrows actually go in both directions because normally this is a buffer system that's going to prevent radical shifts in pH. And where is it? It's found in the blood. It's found in other places. You've seen it in other places, but it's not working so much as a buffer system, like inside of maybe inside of parietal cells. You've seen this, or some other places in the body. But just realize that the buffer system that I'm talking about is located in your blood. In your blood, you have water, you have carbon dioxide dissolved, and you have carbonic acid and hydrogen ions and bicarbonate ions. So these are all in the blood, and it's in equilibrium, so it's going back and forth to absorb hydrogen ions or release hydrogen ions that are necessary to keep our blood pH, because this is a side story. Our blood pH is supposed to be between 7.35 and 7.45. Well, if we get too low or if we get too high, then we're getting out of the bounds of this bicarbonate ion carbonic acid buffer system. This buffer system really does absorb a lot of stuff to make sure that we stay within that range of 7.35 and 7.45. But sometimes, it gets overwhelmed. So what happens if the buffer system fails right here? Which two body systems can take over and rescue you? Well, first body system is going to be the respiratory system, because the respiratory system can either add or take away carbon dioxide, correct? So the respiratory system is one thing, a backup, if this bicarbonate ion carbonic acid buffer system fails, or the urinary system, because the urinary system can get rid of hydrogen ions or it can retain bicarbonate ions, and that's going to affect your pH. Okay, so what is it? This is E. A person has uncontrolled diabetes that leads to diabetic ketoacidosis. And we'll pause for just a second. Let me see how I pause more. Somebody just came into my office. Hold on. Okay, so what is it like if a person has uncontrolled diabetes that leads to diabetic ketoacidosis? That would be DKA, right? What is it about uncontrolled diabetes? Well, first of all, the person has a really high blood sugar level, but they can't. But the sugar, the reason it's so high is because the sugar can't get into the cells, because either their cells are unresponsive to insulin or they're not producing insulin. So if the sugar can't get into the side of the cells, the body is going to be alarmed because it needs some energy. And so what it's going to do is it's going to start breaking down fat and to start as an energy supply to go into the mitochondria. So people who have uncontrolled diabetes can start losing weight because they're breaking down their fats. Well, when they're breaking down the fats, they are releasing ketones, and ketones are acidic. That says ketones. Ketones are acidic. If something is acidic, that means it adds hydrogen ions to the solution. What solution are we talking about? Well, we're in the blood. And so if we add ketones into the blood, what's going to happen is they're going to release hydrogen ions. So we're going to, up here, if we go back to this carbonic acid bicarbonate ion buffer system, we're adding hydrogen ions. So a person has, this is just a statement. I'm telling you more about this, so there's nothing to answer here, really. Give me 1 second. Okay, hold on. Pause again. So on E, when it says a person has uncontrolled diabetes leading to diabetic ketoacidosis, that is just a statement. I added that underneath to let you know that it's the ketones that are going to add hydrogen ions to solution. And then maybe, you'll know that how can DKA affect blood pH? Well, if we're adding hydrogen ions to the solution, then our pH drops because the more hydrogen ions you have in a solution, the lower the pH. And so we're talking up here, if we go to the scale, we're dropping down acidosis, a condition of having acid. So if we scroll down here to G, and then I say, exactly how is the buffer system overwhelmed? Show on the buffer system equation and write the directional shift. I'm going to draw this again because that is up there is messy. But what we have is water plus carbon dioxide. We've already labeled it above. We're not going to need to do that. If these two combine, they form carbonic acid. If carbonic acid breaks down, it's going to release into hydrogen ions and the bicarbonate ions. All right. Now, this is usually an equilibrium. My question specifically is, how is a buffer system overwhelmed? Show on the buffer system equation and describe the directional shift where we're adding hydrogen ions on this far right side of the equation. We're adding here. So if we add a bunch here, the only way that we can control pH is bind them up with this bicarbonate ion to produce this carbonic acid. So if we have a lot of hydrogen ions, we add the extra ones to any bicarbonate ions we can spare, and we shift this equation to the right. And the way we shift it to the right, like I said, we combine our hydrogen ions with our bicarbonate ions to form carbonic acid. And then now we're going to have a lot of carbonic acid. So what can we do there? What can we do there? When we have a lot of carbonic acid, then it's going to break down and release carbon dioxide and water. And so that's how we're trying to get rid of the extra hydrogen ions that we added here. In this situation, which body system can help a person maintain a relatively normal pH and how? Well, this equation is shifted to the left, and so we're creating carbon dioxide, and we know that our respiratory system is designed to get rid of carbon dioxide. And so the respiratory system compensates for this situation, and the patient would hyperventilate, possibly. Patient would. This doesn't always happen, but if the patient hyperventilates, that means they are blowing off excess carbon dioxide. I was going to type this for you, and then there she goes, just writing again. And so this bicarbonate ion is going to be, this buffer system is going to be super important for you to understand because lots of people with diabetes, if it's uncontrolled, it could lead to diabetic ketoacidosis, and that's going to affect quite a bit in the body. And so I'll say that if it's your respiratory system causing the problem, then you had a respiratory acidosis here. How did you handle it? You had a urinary or a renal. Sorry. I am totally on the wrong thing. If it wasn't your respiratory, I saw that carbon dioxide. If it was something other than the respiratory system, so please just take that out of your mind. Like diabetes is considered a metabolic acidosis. And who do we have compensating for this? The respiratory system. So that will be a respiratory compensation. Now, in addition to the respiratory compensation, you can also have renal compensation. So we're going to add the renal system in here. If you have too many hydrogen ions, the respiratory system, well, if you have too much carbon dioxide, that'll blow that off. But also the renal system, kidneys, can secrete, meaning get rid of extra hydrogen ions and resorb bicarbonate ions. So you'll have more of this guy in your blood and less of this guy. So that's the answer to number 1, if you get that question. I think that I will keep these questions separated and do them one at a time. And so that's how you answer number 1. And I break it down for you in such a way, hopefully, that you'll be able to get points on this, if not a 100. Most people do quite well. So that's the end of question 1. We'll start the next one with question 2.